announcement of this company's breakthrough came through, I believe, less than 2 weeks ago, and we were able to slot them. We literally saw this in the newspaper, so we have to have Dr. Lee Hung Wing to come and speak to us. And I mentioned earlier when we were kind of setting up the pitch section that they have developed a test, a non-invasive test for Alzheimer's. I mean, this is something that has been so tough for people to track down and to get out ahead of. And, you know, the breakthrough has happened. Now it has to be commercialized. She's going to come and tell us about it. And like I said, when I called her, I said there were two things about this. Number one, when this test is on the market, I'm going to Watson's, in Hong Kong and taking it like every week to see if the Alzheimer's has got me yet. I mean, I think I'm already there. My wife swears it's there. The second thing was about women in science. And I said, yeah, I know you were part of a team, and there were a lot of people in the team, but I want my daughters to see people like her coming to the forefront and seeing women making breakthroughs in science. And at NexChange, we're really keen on that. And she said, Andrew, I can come. So ladies and gentlemen, please welcome from Baptist University, Associate Professor in the Chemistry Department and Hong Kong hero, Dr. Lee Wing Hung. Dr. Lee Hung Wing, please, Dr. Lee, join us. Come. Now is your time.
Thank you.
Yes, a strong finish to the day. Thank you.
Thanks, Andrew, for the chance to be here to share with you our research, basically. Again, I'm Ho Wing Lee. This is our research, okay? We are working at the Alzheimer's disease from different aspects, detection, diagnostic, and also to therapeutic. So some background of AD, Alzheimer's disease. Probably you may know that this is the most common neurodegenerative disease that causes many troubles, okay? Not only cognitive, but later on it will be the behavior, your action. And sadly, this is an age-associated disease, but incurable, and the cause of this disease still unknown. Okay, so this is some of the statistics for the AD. It might be scary. Over the world right now, we have about 47 million suffering from the dementia. And in 20 years, it's expected to grow by double. And in 30 years, by 2050, that the estimation is 130 million. So as you see, this is a kind of placing us a big trouble, not only social trouble, but also economically. And in Hong Kong, of course, we cannot escape because of the aging population. There are some challenges, okay, for the AD so far, because as I said, this is the disease mechanism or the reasons for the disease is still not well understood. And so the challenges over the world so far is we hope to have early detection, as what Professor Chen just said. The early detection may help with the treatment or early intervention. And second will be the diagnostic, which is sensitive and accurate, and followed by the therapeutic to prevent and also the, improve the AD progression or reduce the progression. So in our research group, actually what we developed is a group or a new class of chemicals, which is a kind of a so-called a class of cyanine. This here shows you the basic skeleton of the chemical structure in this class. And generally, this cyanine, what we found out, they are being non-toxic to cell and neuron, and they also have very high selectivity and binding affinity to the A-beta species, and later on I will tell you about the tau and p-tau, phosphorylated tau protein. The other properties of this cyanine is once they bind to the protein, they will so-called a turn-on labeling dye. It means that when they are free, the cyanine compounds are free, they are not emitting light at all. But when they bind to the protein, they will emit light at a very high signal. So this will allow us to have a good sensitive detection for the species that we are interested. And the last one, if we are opening up for the therapeutic of AD, the capability to pass the BBB blood-brain barrier is also one of the important properties or criteria for such compounds. Okay, so here I showed you the category of 3 parts that we are working on. The first one is to develop the cyanine into the compound for the early detection of the AD, which is hopefully we proved through, okay? ultra-sensitive, fast, cheap, and accurate. And we also doing some development on the MRI imaging, which is also aimed for AD diagnostic. And lastly, we are working on the animal model, which is basically the transgenic mice to look at the effect of these signs on the AD. Okay, so let's focus on the detection, early detection of AD first. Okay, so out there clinically, there are 3 biomarkers which are well established as for the diagnostics in AD. So including the A-beta 142, which is a very small amino acid peptide, and total tau, and as well as the phosphorylated tau 188. So in this project, we focus on these 3 protein biomarkers for the AD. And the table here shows us that this is the internationally established biomarkers threshold for the 3 different protein biomarkers. As you see, the content of these proteins, when it being diagnostic with the AD, they have the threshold showing here, range from several tens to 100 picogram per mil. So this is not at high content at all, they are at low abundance. So our technique is based on using the nanoparticle, so it is nanocompass. We made the magnetic silica particle where we can conjugate, probably we don't have the laser pointer, do we? Oh yes, okay, good. This is the magnetic silica nanoparticle where we can conjugate an antibody. And as you know, antibody is highly specific to our target. So if we have our target protein biomarkers, it will be captured. After capturing, we further add in the secondary antibody. And then lastly, that will be the sign-in, which is turn on fluorescent labels, okay? So when they get hooked up in this compass, it will be a very bright nanoparticle. And under the fluorescent microscopy, basically we can visualize each individual bright nanoparticle, okay? And the brightness will be correlated, highly correlated with the amount of the target antibody here. So we are relying on the brightness of this fluorescent intensity to quantify the amount of the protein biomarkers. And what we find is this is very sensitive, and only to detect the biomarkers in CSF content, as I showed you in the table, but also it is capable, because it is more sensitive, to detect these 3 biomarkers in saliva as well as in urine, which is at very low abundance. Okay, again, the selectivity is also still come from the sign-in, okay, which show you the turn on signal. So we made a comparison with out there, the commercially available ELISA and the XMAP, which is well-known, a new technique for the detection of these 3 biomarkers, as well to compare with ours. What I want to show you is we are using less sample volume, which is the real sample volume, and also the detection range is much lower than those commercially available. The other important point is the analyze and the time which to use to analyze is also much shorter than the other 2. And this is just the reagent cost, okay, without labor cost, okay, comparatively it is cheap. Okay, so thank you for your attention.
Well done, with 20 seconds to spare, right on time.
Yeah.
So, Dr. Lee, we're gonna throw it up. We're gonna see if we get a couple of questions going, and I'll ask the first one. So this is the scientist. This is the science. You are the scientist. But of course, the next step is going to be to commercialize this. And can you talk a little bit about the business side of it? Because we've got a lot of investors here today, whether they're early stage or later stage. But can you talk a little bit about, what the plans are, whether it's for the protection of the IP or the commercialization of these tests?
So as you say, we developed as a kit tool, okay, a kit to sense or to detect the low abundance protein biomarker. In fact, this approach is not just limited to the AD biomarkers. It could be, not just limited to these three, like A beta, tau, p tau. It could be any other antigens, other protein base, okay? Because we still have quite a number of the SINE which show different selectivity and also the binding affinity. So we hope to open up a new path for commercialization, and also we also hope it can work to our community, not just with the basic research result.
Have you got IP lawyers on the job already? Have you got intellectual property lawyers that are protecting your data already? Is the university helping you with that?
The compound, the class of the compound, we have the patent.
Oh, you do have the patent in place already. Okay,
Yeah.
good. And have investors been coming to talk to you since the news broke last week or 2 weeks ago?
Yeah, 2 weeks ago.
Yeah.
We have the NGS approaching us, so this is for the community service, because they can offer us a lot of the patient sample, no matter which stage of the AD. So
Okay.
there
So
will be a good opportunities to draw better impact.
Okay, so, again, very clearly focused on developing the product and the solutions. But if you're one of the investors, you might want to come and talk to her, because it sounds like they still have to get to her. So the path is clear. So ladies and gentlemen, please, big thank you for Dr. Li Hong Wing from Biomarkers.
Thank you very much.